Hello again. Today we are focusing on angles and radian measures. So in this lesson you're going to learn how to draw angles in standard form. You're going to learn how to find coterminal angles, and you're going to learn how to use radian measure and how to convert degrees to radians and radians to degrees. This is something that is one of the standards in SAT. So if you're planning to take the SAT, this is something, a lesson that you do need to know. All right, so we're going to look at this picture over here. There's a lot of parts to this. The angles in standard position. So this is actually showing an angle in standard position. In a coordinate plane, an angle can be formed by fixing one ray. So the one ray that we're fixing is this side here, and we're calling it the initial side. So we're fixing that one, so that one's going to stay put, and then you're going to rotate the other side. So that it's the initial side is the fixed ray, and then rotating the other ray, called the terminal side, about the vertex. So this point here is our vertex. And then if you rotate it, this is called the terminal side. So we've got the initial side and the terminal side. And we're going to be drawing these arcs here to represent the amount of rotation that we are making. So this is representing the rotation. When you're looking at the coordinate plane for the radian measure, we are looking at your degrees. 0 is the starting point here. So if the terminal side and the initial side were matched up, that would be 0 degrees. As you go up and around to the left, so that's counterclockwise, you hit 90 degrees, and then a straight line would be 180 degrees. If it rotated 3/4 of the way around, it would be 270 degrees, and then rotating all the way around back to the beginning would be a rotation of 360 degrees. So moving on, an angle that's in standard position, or an angle is in standard position when its vertex is at the origin, which is the point 0, 0, which we have here, 0, 0, and its initial side, which is the fixed side, lies on the positive x-axis. So basically it means it's going to start at 0, 0, and it's going to be going to the right. So that's your initial side. The measure of the angle is positive when the rotation of its terminal side, so not the initial side, the one that you're moving around, is counterclockwise. So it's got to be counterclockwise, which means it's going to go up and around. So it's going to start here, and then it's going to go up and around this way. So that's positive. It's negative. The measure of the angle is going to be negative when the rotation of its terminal side, again, that's the one that's moving around, is clockwise. So negative, kind of think down. So it's going to go, starting from the initial side, it's going to go down and around. So if this was the initial side, it would go down and around that way. So that would be negative. And this would be your terminal side. And then if this was your terminal side. So this is a positive rotation, this is a negative rotation. Okay, so now that you know what's positive and negative, we're going to practice drawing some. So that's one of the things you're learning, how to draw angles on the coordinate plane. The first thing you want to identify, so example 1A, this is a positive angle. And the other thing I'm going to do is I'm going to write down my degrees. So I know that I'm going to start my terminal side or not my terminal side, my initial side is going to start at 0, 0, and it's going to go to the right. But this, if there was no rotation, it would be 0 degrees. So I like to put my degrees around the circle. So I've got 0, and then up here I would have 90 degrees. All the way to the left would be 180 degrees. This one down here is 270 degrees. And then all the way back to the beginning would be 360 degrees. So if we are rotating a positive 260 degrees, that means we're going to start here and we're going to rotate up and around till we get to almost 270, but not quite. So these aren't going to necessarily be exact, but you do have to draw the terminal side. So we've got our initial side, we've got our terminal side. So initial side, and this is our terminal side. But you also have to show the arrow of rotation. You have to show that it's starting here and rotating around to here. So this little circle thing here with the arrow is part of your drawing. You have to draw that, and it has to be precise. So you're starting at the initial side, and it's going to rotate around to get to the terminal side. And that's your 260 degrees. And a lot of times what we'll also do is write 260 degrees there so that we understand that's going around a positive 260 degrees. All right, so that's one example. That one's an easy one. The next one is a negative angle, but some of you are thinking 750, are we going to have really numbers that are that big? Yes. But because it's negative, rather than labeling my axes or my four sides, the 0, 90, 180, and 270, I'm going to actually go the counterclockwise. I'm going to go counterclockwise, and I'm going to use negative numbers. So again, this starting point would be 0, but instead of rotating up, I'm going to rotate down because I'm going the negative direction. So down to here would be a negative 90 degrees. If I rotated another to the next line, it would be a negative 180 degrees. Then I would go backwards this way, would be a negative 270 degrees, and then all the way back to the beginning, clockwise, would be a negative 360 degrees. Well, 750 is more than 360 degrees. So we need to figure out, well, how many times do we have to go around to get to negative 750? So that when your number of degrees is bigger than 360, that means you're doing more than a full circle rotation. So negative 750 degrees is equal to negative 360. So the way I'm going to calculate this, I'm going to use my calculator and take my 750 minus 360. Oops, delete that. That gives me 390, which is still above the 360. So I'm going to have another negative 360. So if I subtract 360 from 390, that gives me 30. And that gives me, so that means I have another negative 30 degrees. So negative 750 is going to equal negative 360, another negative 360, and then a negative 30 degrees, which means we're going to have to make 2 full circles clockwise and then another 30 degrees clockwise. So when you're doing this, you have to be precise. It has to look exactly or almost exactly like my drawing. Draw your initial side. Again, I'll label that initial side. You don't necessarily have to label it as long as I can see it. Now, when I'm drawing my rotation, this thing here, I'm going to start at the center, kind of close to the center, and then I'm going to go around in a circle, but do not connect it with your initial point. You're going to go on the outside of it. So when I start here and I'm going to go around, that's negative 360 degrees from here to there. But I have to do another negative 360 degrees. So I'm going to start here and go on the outside of that. It's like a spiral, and then it ends here. So that's negative 360, another negative 360. Now I have to go an additional negative 30 degrees. So if this is 90, 45 is halfway, 30 is about a third of the way, right there. So that's where I want my terminal side. So I'm going to draw my terminal side now, and the arrow here. So that's my terminal side. So you have to, the spiral has to look just like this. So I always start towards the center when I know I'm going to have to go more than one full circle. So start here, go around, negative 360, another negative 360, and then negative 30 degrees more for a total of negative 750. But the spirals show how many times you've gone around. Okay, so that is how we draw angles in standard position. Example 2. The directions ask us to find one positive angle and one negative angle that are coterminal with the given angle. So again, you're given an angle. This one's positive, this one's negative, so we've got a couple good examples. So the positive 55 degree angle, if I were to draw it, this would be my initial side. Since it's positive, I'm going to go up and around. But remember, this is 0 degrees. This is 90 degrees on the positive direction. So 55 is going to be a little bit past halfway. So approximately right here. So that would be my 55 degrees. Okay, so there's my 55 degrees. Well, what does it mean to be coterminal? So this is a definition you definitely want to write down and you want to know. Coterminal basically means you have two angles whose terminal sides so the terminal sides, the one that ends, so this is the terminal side, coincide, which basically means they end at the same point or the same place. And the way that you basically do this, so these things are found by adding or subtracting 360 degrees one or more times. To the original measurement. So if we're starting with 55, we could just take the given angle, 55 degrees, and add 360 degrees. Because that would mean that I'm going 55 degrees, but then I'm going another full circle from there, so that would end up being the same terminal side. So if I just add that together, I would get 415 degrees. So that would be considered a coterminal angle. If I wanted to, I could add 360 degrees to that, and that would give me another coterminal angle, or I could add 360 again. So basically your coterminal angles are going to be plus or minus 360 n. So you can go 360 degrees in the positive or negative direction over and over again. So that's our directions, though, tell us to find one positive angle and one negative angle that are coterminal. So this is a positive angle that is coterminal to this. If I were to draw it, so I guess I'll use the blue since I used the blue for the 415. So again, I'm going to start at 0. I'm going to go around 360, go on the outside of that spiral, and then go another 55. So that would again end the same place as the original one did. Well, now I want to find a negative angle. So I want to have a positive and a negative angle. So instead of adding 360, I'm going to subtract. Now, I will tell you that sometimes you have to subtract more than once, or you might have to add more than once to get a positive or a negative degree. But with 55, you don't necessarily have to. You can just subtract 360 degrees, and you will get a negative 305 degrees. So that is a negative angle. When you draw it, since I've already used up this space, I'm going to start here. I'm going to go on the outside, but I'm going to go down and around, and I'm going to end up here. So I'm not going a full circle. It's only negative 305. So this would be negative 90, negative 180, negative 270. So a little bit more would be the negative 305. And again, it would end here. So we've got 3 terminal sides that coincide. You've got the 55 degree, you've got the 415, and you've got the negative 305. Okay, hopefully that made sense. We're going to do one more with a negative angle. So with the negative angle, you want to make sure that your initial side is starting from the vertex at 0, 0 and going to the right. But since I'm going in the negative direction, I might want to label these as negative 90 degrees, negative 180 degrees, negative 270 degrees. So the negative 300 is going to be 30 degrees past the negative 270. So I'm going to draw this. I'm going to show it with the red here. So I'm going to go all the way around this direction, and I'm going to end my terminal side about right there. I just realized with my initial one here, I never showed this arrow. So starting from 0 going up to 55, that was the initial 55 degree angle. So this one here is the initial negative 300 degree angle. So this is your initial side and your terminal side. So now we want a positive and a negative angle that end at the same place. So the positive angle probably is pretty easy. If we go from here to there, we'll get a positive angle. But what will the measurement of that positive angle be? Well, if you take negative 300 degrees and just simply add 360, you're going to get 60 degrees. So this here is a positive 60 degree angle. To get a negative angle, we're going to take the negative 300 degrees. So negative 300 is already a negative angle, but we can't use this for an additional. You're supposed to find one positive and negative that are coterminal with the given. So you cannot use the given angle as your negative angle. So instead we're going to subtract 360, and that will give us negative 660 degrees. So I'm glad I labeled these with the negative numbers. Remember, when you get all the way back to the beginning, that's going to be a negative 360 degrees. So the negative 660 will be a full circle in the negative direction, and then 300 more in the negative direction. Okay, so again, I don't want to overlap the other spirals that I've already drawn. So I'm going to start here, and I'm going to go around. I'm going to go back to the starting, but again, don't connect these. This should be a little bit outside of the starting place. And then I'm going to go around all the way till I get to this side here. So all of them end. So I've got all of them ending at the same place. So I've got the orange, the navy dark blue, and the turquoise blue all ending in the same place. So they're all coterminal. And then if we had to give the measurements, it would be 60 degrees and negative 660 degrees. Okay, so that's page 1. Hopefully you understood those examples. Now we're moving on to page 2. So page 2 is converting between degrees and radians. You would benefit from knowing that 180 degrees is equal to pi radians. So we're not using 3.14 for pi. We're just using the symbol for pi and saying pi radians. So radians is a unit of measure. So if you're given a measurement in degrees and you want to convert it to radians, we use this conversion rate. So from degrees to radians, you want to multiply the degree measure that you were given by pi radians over 180, or what we're going to just say is pi over 180, because we want to get rid of the degrees, so we want to get the degrees on the bottom and we want to be left with pi or radians, so we're going to put the pi at the top. If in the opposite you want to, so this was degrees to radians. If you want to convert from radians to degrees, you're going to multiply the given radian measurement by 180 over pi. And again, you don't have to write out the word radians right now. You just know pi over 180 or 180 over pi, because 180 and pi are equivalent, but one is in units of degrees, the other one is radians. Okay, so the first two examples here are in degrees. So if it's in degrees, let me look at my notes here for a second, make sure I'm not missing anything. So if it's in degrees, what I would recommend is that you make it a fraction, put it over 1, and then we're going to multiply by our conversion rate. Since I want to get rid of the degrees, I want to put the degrees on the bottom. Well, 180 is your degree measurement, and the 180 degrees is equal to pi radians. So that's our conversion factor. Now if we multiply across, we would get 45 pi over 180. But you don't want to necessarily leave it as 54 over 180. You want to reduce that. So think of a number that both 54 and 180 can be divided by. And the first one that comes to my head is 9. So if I divide both the numerator and the denominator by 9, that's going to give me 6 pi over 20. So now I realize, well, I could have divided by something bigger, but that's okay. I can now divide both of them by 2. So if I divide by 2, I'll get 3 pi over 10. So 54 degrees is equivalent to 3 pi over 10 radians. And that's our answer. Okay, well, what about a negative? Negative is treated just like a positive. If you're converting from degrees to radians, you want to take that negative 310 degrees. I'm going to make it a fraction by putting it over 1. Since I want to get rid of the degrees, I'm going to put the 180 degrees at the bottom, and I want to convert to radian, so I want pi in my answer, and then multiply across. So 310 pi divided by 180. At this point, we want to reduce, so we can see both of them end in a 0, which means we can divide both of them by 10, which will equal 31 pi over 18. Well, 31 is a prime number. It cannot be simplified anymore, so we have our answer. 310 degrees is equal to 31 pi over 18 radians. And there you have it. All right, so that's going from degrees to radians. Well, what if you're given a measurement in radians or with a pi, and you have to convert to degrees? Okay, so do it this way. So 16 pi over 15, then we're going to multiply by the conversion factor, but since we want to get rid of pi or reduce the pi, we want to have the pi in the denominator. And pi is equivalent to 180 degrees. So we want that in the numerator. So the pi then will reduce in the numerator and denominator. And we could probably reduce the 180 and the 15, but I think I'll wait to do that in my next step. So I now have 16 times 180. Okay, so we have 16 times 180 over 15. And 180 does have a factor of 15 in it, so we can divide both the numerator and denominator by 15, which will give us 192 degrees. So 16 pi over 15 radians is equal to 192 degrees. So we've just converted from radians to degrees. All right, the next example is a negative measurement, negative angle. But again, you're going to simply multiply by that conversion factor. Since we want to get rid of the pi, we're going to put it at the bottom. And we want to put the 180 degrees at the top. So your pi reduces, and we would have 2 times 180 divided by 5. So the 5s would reduce, and or you could just multiply then divide. Either way. Oh, but we do have a negative here. Don't forget the negative. So it's going to be negative 72 degrees. So the negative 2 pi over 5 radians is equal to negative 72 degrees. All right, so next up you see this unit circle. Don't let it scare you. It's something that is very useful. And if you are going to be taking pre-calculus at some point, you're going to have to, it would be very helpful for you to memorize at least the first quadrant here. So this is what we call the first quadrant. So 0 radians is equal to 0 degrees. 180 degrees is equal to pi. So we have on the outside you can see the radian measures. On the inside you have the degree measures. If you divide 180 by 2, you get 90. So pi over 2 is 90. If you divide that in half, you get 45 degrees, or pi over 4. So those are kind of easy to remember because it's half of 180, 90, so pi over 2. Half of 90 is 45, so pi over 4, which is half of pi over 2. These two are a little bit harder to figure out, but again, it goes with the conversion. So if there are 180 degrees in pi, well, 30 is 1/6 of 180. So 30 over 80 would be 1/6 pi, or pi over 6. 60 degrees is 1/3 of 80. So 60 over 180 is equal to 1/3 pi, or pi over 3. So if you can memorize those, then these ones, the rest of them come easier because they are just multiples of the others. So I've got some notes here. I know it's a lot of reading, but in general what we're doing is we're taking the degrees, we're looking at the degrees and radian measures of special angles. So our special angles are the ones that are on the unit circle. So there's not, you don't see every single degree on here. It's just the 30, 45, 60, 90, all of those that are going up by 30s or the 45s in between. Okay, so the diagram shows equivalent degree and radian measure angles for angles from 0 to 360 degrees, which is also equivalent to 0 to 2 pi radians. So 360 degrees is equal to 2 pi. Because if 1 pi is 180 degrees, then 2 pi is 360 degrees. So that's something that you would benefit knowing. And here's where they say you may find it helpful to memorize the equivalent degree and radian measures of special angles in the first quadrant. So again, especially if you are going to be taking trigonometry or pre-calculus, that is something that you want to memorize. And 90 degrees is equal to pi over radians. All other special angles shown are multiples of these angles, which you'll learn more about when you take trigonometry or pre-calculus. So first thing we want to do is we want to, so in these couple examples, all we're doing is using the unit circle to convert these. We could use the conversion factor and multiply the degrees by pi over 180, or multiply the radians by 180 over pi, and we could simplify it the way we did the last example. However, if you're given the unit circle, just look at it. So if I'm trying to find 135 degrees and what that measurement is in radians, I just look at my unit circle. Here's 135 degrees. In radians, it's 3 pi over 4. So that's all we do is look at the circle, and that equals 3 pi over 4 radians. And that's it. So it's nice when we have the special ones. Negative 45. So this one's a little bit trickier because we have to go in the negative direction. So if you're going negative 45 degrees, that means you're going down and around. So that's going to end up at 350. So 315 degrees is coterminal with negative 45. So that's going to be, actually, okay, I was just looking at my notes from last year. So it's actually not going to be 7, I was thinking 7 pi over 4, but it's not. It's actually going to be, if we factor that negative 45 into negative 1 times 45 degrees, and then we look at 45 degrees is pi over 4. So if you start with a negative degree, you want to end with a negative radian. So it's pi over 4. So if we just take negative 1 times the pi over 4, it's just negative pi over 4. So that's how you treat a negative. You just make it negative, but you use the same measurement as 45, which is pi over 4. Okay, well, what if you're given a negative radian? So this one, again, is going to equal negative 1 times the 5 pi over 4. So we're going to look at our unit circle for 5 pi over 4 to see how many degrees is 5 pi over 4. So we're going to look around our unit circle. Here's 5 pi over 4, which is 225 degrees. So negative 5 pi over 4 is basically negative 225 degrees. All right, so that's pretty easy. And the last one here, we've got 5 pi over 6. So again, it's positive, so we don't have to worry about changing it to negative, but we're going to look on our unit circle for 5 pi over 6. Here it is. So 5 pi over 6 radians is equal to 150 degrees. So that's how you use the unit circle to find measurements of special angles if you are given the unit circle, which you will be given the unit circle. You do not have to memorize it at this point in time. You will, though, probably have to memorize it for pre-calculus or trigonometry. Okay, so what else do we have? We have arc lengths and areas of a sector. Okay, let me get my notes here. So let's first of all define what is a sector. This is something that, again, you should be kind of familiar with. The sector is basically the area of the inside of the circle, but inside of that angle. So more precise, it's a region of a circle bounded by two radii, which is plural for radius. So radii, that's how you spell it, two radii, and an arc on the circle. So here's our sector. You've got the radius here and the radius here and the arc. So this sector is bounded by the radii here and here and your arc length. So it's the area of that shaded area. All right, so central angle is another term that you need to know, and you should have heard this before. Central angle is the angle measure the angle measure of a sector of a circle. So this measurement here, the measure of this angle is the central angle, and we'll call that theta. So the angle measure of a sector of a circle. There are a couple formulas that are given here. So if you're trying to find the arc length, so the arc length, we use the variable s, I'm not sure why, and the area A of a sector with a radius r and a central, so that's the radius, a central angle theta that is measured in radians. So that's very important. It has to be measured in radians. R as follows. So this is our formula. So the arc length, S, is going to equal the radius times the theta, or the angle measure, in radians. The second formula for area, so if we're trying to find the area of the sector, it's equal to 1/2 the radius squared times, again, that theta, but the measure of the angle has to be in radians. Okay, so what else do I want to point out? So area of a sector. That's not really explained on there. So this is the formula for the area of a sector. Okay, so here we have an example. It's a softball field, and the softball field forms a sector with dimensions shown. And we want to find the length of the outfield fence and the area of the field. So the outer field fence is basically the arc. So if we're wanting to find the length of that fence, we're basically finding the arc length. If we want to find the area of the field, then that's the area formula. So the area of the field, we're going to use the area of a sector formula. And for the length of the outfield fence, this is basically the arc length. So we have to find both. So under arc length, I'm going to do the arc length, and then the area of the sector, I'll do it over here. So I would start with my formula. The formula for the area of a sector, A, equals 1/2 r squared theta. But remember, the theta has to be in radians. So if we have a 90-degree angle, what is that going to be in terms of radians? Well, you can either look at your unit circle, Or if you know that 180 degrees is equal to pi, then 90 degrees is equal to pi divided by 2, or pi over 2. So our angle is going to be pi over 2. The radius is 200 feet. But don't forget you have to square it. And then you have this 1/2 out front. So using our order of operations, make sure you square before you multiply by either one of these things. Although we could multiply the pi over 2 by the 1/2 first and then square the 200. So if I did that, I kind of like that idea. So the 1/2 of pi over 2 would equal pi over 4. 200 squared would be 4 with 4 zeros, or 40,000. So then the 4's would reduce and we would get 10,000 pi. So the area of the sector is 10,000 pi. Unit of measure, feet. So feet squared. So there's our area. And in case you didn't get that here, the 90 degrees is equal to pi over 2 radians. Okay, now we're going to find the arc length. So the formula for arc length was S equals R theta. So R, again, the radius. Theta is going to be pi over 2 again. And the radius is 200. So our arc length is 200 pi over 2. So the 200 and the 2 can reduce. And our arc length will be just 100 pi. Since it's a linear dimension, it's going to be feet, not feet squared like the area was. Okay. If you were asked to write this in standard form rather than in terms of pi, you would then want to multiply the 100 times pi. And so if we think of pi being 3.14, 3.14 times 100 would be approximately 314 feet. So that's if you want to write it in standard form rather than in terms of pi. If you wanted to write the area in terms of in standard form, you would again probably take pi on your calculator. So if I take pi times my 10,000, or just type in 10,000 pi, you're going to see that the decimal point's here, so it's 31,416 feet squared. So the area is approximately 31,416 feet squared. Okay, and then last but not least, we have one more example for A, B, and C. We're going to use our calculator to evaluate the trigonometric functions. Again, on a quiz or test, I will not be able to tell you how to do this, so you have to practice it often enough so that you know how to put this in the calculator. Okay, so if you are given a measurement that is in terms of radians, you have to either convert your radians to degrees and then put it in your calculator, or you have to change your calculator from degrees to radians. So with these calculators, the way that you would do that would be to try to remember here, DRG. Yes. So the DRG button, you can see degree, radian, and gradians. But we don't use the GRD very often. But degrees and radians are what we're going to go between. So you want to convert your calculator to be in terms of radians. Make sure that when you're using your calculator for other things, you change it back to degrees, or else you're going to get some really strange answers. Okay, so we're going to put it in terms of radians, hit enter or equals. Now we're going to type in sine, and then we want to make sure we put the 3 pi over 5 in parentheses. So sine 3 pi divided by 5. Close my parentheses, hit my equals, and I get my sine is approximately, so I'll put it underneath, it's approximately 0.9, let's see, it doesn't tell us what to round to, so we're going to go 3 decimal places. We're going to go to the thousandths. So 951. So we just converted it to radians, or not converted to radians. We just found the measure of sine 3 pi over 5 radians. All right, so the next one now, if you look at it, it has secant. Well, secant isn't on our calculator, but we have to go back and remember, well, what does secant represent? Secant theta, so if we remember, secant theta is the inverse of cosine theta. So if cosine, so the other way that we can write it, or secant theta equals 1 over cosine theta. So in the last section, when we were doing the 6 trigonometric functions, I mentioned that when you're using the calculator to calculate secant or cosecant or cotangent, you're going to want to take 1 divided by the cosine of your angle. So we're going to take 1 divided by the cosine of, and then in parentheses, you're going to put your 8 pi over 7. So again, we've converted our calculator already to radians. I'm going to take 1 divided by cosine, and then it gives you the left parentheses, so now just type in 8 pi divided by 7, close the parentheses, and hit your equals. And you get negative 1.10, or let's row to 3 decimal places. So if I go to the 3rd decimal place, that 9 is going to round up to a 10, so it would be 1.110 would be 3 significant digits. And there you have it. All right, so the last one is cosine, so we don't have to worry about taking 1 divided by anything. The problem with this one, though, is that it's negative. And if you try to plug in a negative value, I think you're going to get an error. Let me double check that. So let's try it. Cosine negative 2 pi divided by 3 equals, oh, it gave us to us. Okay, so I guess the negative is not an issue. All right, so just plug that in your calculator. Again, make sure your calculator's in radians, not degrees, and then you get negative 0.5. And that's it. All right, that's the end of our notes here, I think. Yep. So, hope you enjoyed it, and I hope you understand it.